Hello, everyone. Can you guys hear me?
Yes.
Okay, great. Thank you. All right. Welcome to ITS 372. This is really giving me some flashbacks of the pandemic, which I'm not crazy about. Anyway, so let's try to do this, see if I remember. So I'll be doing the same thing as before. I'll be recording the video in a sec. Today we have a lecture, so we'll go over some material of Unix, some of the main concepts, and then we'll go over some ideas and then practice those ideas on the virtual machine. We should be back in the lab on Thursday, so there we'll touch base on the homework and everything like that. So I think today is just going to be more of a lecture and then go through the virtual machine. So I got my notes here. It's going to be related to, the UNIX way, which is that lecture. I changed that to a PDF given that the Word documents, or sorry, the PowerPoints have been breaking soon, and I really don't want that to happen while we're doing this. But I think I left the PowerPoint there as well. So yeah, so we'll go over those notes and then we'll go over the handout. And then we'll plan we'll talk about the homework really on Thursday. All right, so let me go ahead and I guess start the recording first, I suppose. And please, if you have a question, if you're going to say something, please just like try to speak up. I believe your microphone, you should be able to unmute your microphones, I assume. And just, yeah. All right, so it says here, stop recording, pause recording. So I assume it is recording already. Okay. All right, so this is recording then. To admit some. Okay, so let's go ahead and start sharing the screen. All right, so you should all be seeing I'll be like narrating what you need to be seeing. Should all be seeing Brightspace right now. And then I have the virtual machine on already, I believe. Somewhere here. So we'll kind of end up today with the virtual machine, just going over some commands. Okay, but we'll start here. So let's take a look at Brightspace. So we have basically completed intro, which was what system admin, some basic introduction commands to the Unix operating system. We've started practicing something. We'll do this a lot throughout the semester, combining it with Linux and system administration. So we've gone over this, the Linux command, the cuckoo's egg, quite a bit there. So, all right. So today we are going to focus on these two things. I haven't created the homework yet, but we're going to talk about the UNIX way, which is this PDF. And there's quite a bit there. And so we'll cover that. And then I have this Word document, which is a set of Linux commands. So we'll go through those today. I'll be discussing those commands. And then on Thursday, we'll do some more and then talk about the homework assignment. All right, so there is, as usual, a set of PowerPoints for you guys to read. It's just your managerial topic. So this week we're talking about services as one of the topics. We've talked about them a little bit last week, and we're going to continue to do that. today. And yeah, so we'll talk about services, but these slides also include talk about services, but more from the managerial point of view. They'll talk about workstations, servers, and then servers provide services like web services, etc. So, okay. And so please, as usual, just read through these. Remember you may have some questions on the exams related to that. Workstation. I went over them this afternoon. That it should be something that's pretty straightforward to read through as part of your reading material. So at the heart of today, really, the central topic will be this one, the UNIX way, basically, this PDF. I'm going to click on it. We're going to go through it. I am currently in the process of digitizing everything, all my notes, everything, but this one hasn't made it through digitization yet. So hopefully future classes will have, this like in a website or something like that. But for now, you have a PDF of it. And then, as I said, a lot of these relate to just ideas of how Unix works. And so we'll go through it first just to kind of talk about the ideas. What is the UNIX way? There's a very nice documentary I was watching the other day about the history of Unix from the very beginning, from those guys, Dennis Ritchie and the other guy. So I may post that at some point for you guys to take a look. I thought it was very interesting. Anyway, that UNIX way really comes from a lot, right? So that video really gives you context of how they were very limited really by the hardware, right? So even at big companies, they had like one computer. This is in the 60s, late 60s actually, where the story begins. But yeah, they were working on, various things, various software. Eventually, they started to write software that actually they could run on several operating systems, different operating systems. And, this is before like even Windows, obviously, and obviously Unix. I mean, we're talking way back when. So anyway, that's a good, interesting history that you should take a look. But in general, they eventually arrived at a software that kind of started to become this operating system. They really just wanted to run software and these, like almost like mainframes. So there were like the big mainframes, and then there was like a tiny, gigantic mainframe, the size of a refrigerator, but it was, it's a mini, I think they were called mini mainframes or something. Anyway, so yeah, that's the story. But eventually they started to develop the operating system. And the philosophy really, as I've said throughout the class, is that Linux just became, files. The Unix way basically is files. You could say, and then access control. Okay. So that's kind of the idea. The Unix way is files, basically. So here I have some notes. So the Unix way, files are, files are control to Unix, really. Unix, they're central to the operation. Remember that we've discussed that Unix has a hierarchical directory organization. And we can see that there. So remember, we've talked about the root, which is the /, and then within that we have home, bin, etc. Right, all the other directories. So and this is usually known as the file system, right? So the file system is central, that organization, how to attach drives, all of that functionality was actually really important back then. So because everything is a file, then you will usually have users, right? Or groups, and then you basically have file ownership and file access control, which is really important. And again, even, when we talk about Unix and sysadmin, at a very basic level, we're talking about security of operating systems through these ideas of access control. So today and Thursday, we'll be practicing some of these commands, such as the ones that you see here. But today, I like this kind of summary lecture, as it has a lot of very important topics, of the fundamental things. So file ownership. Okay, so we have that idea. We know that on the command line, to remember that this is a $, right? And that indicates regular user. We can type commands such as cd to navigate into folders, and then we can type ls-l, and that allows us to see permissions. So on Unix, files have 2 owners. We will see this when we start. You've seen it already, but we'll emphasize it more today. So we have the user owner, and then we have the group owner. So the user and group owners are independent of each other. And usually when you create an account, you create a group also of the same name, and that user is basically part of that group. So let's think of a quiz. This is not an actual quiz. It's more of an exercise, mental exercise to think about. But suppose Smith, right, who is in the chemistry group, needs access to some files usually used by the physics group. If you're the SA or the system administrator, how do you give her access, Smith, to this group? Because she wants to be able to use this file. So basically, the solution would be to make Smith a member of the physics group, right? The group physics has access to the file. Smith does not. And so the idea with Unix in general is that you would assign a user to that group. You would not, of course, make the file accessible to everyone, right? That would be the bad approach to this. And so hopefully this example illustrates basically the way that this should. Any questions about that idea, guys? Making sense? Yeah. I assume your silence means everything is clear. Okay. Okay. I think you guys can still hear me. All right. So let's continue then. All right, so let's look at the commands associated with these operations. You can see here, for instance, the basic command. Notice that in here, where you see the mouse hovering over a £, that also indicates the terminal, the command line. And remember that when you see a £, when you see a £, that means that something is basically root. All right, so that means that this is root privilege. Here we have a command, chown, and that's the command. Ch stands for change, owner. So as we've stated, a file in the file system will have an owner and a group. And so chown allows you to change the owner. So for here, the example is we have a file data.txt, and we can change the ownership by just doing this. So owner space, Harvey space, and the name of the file. So in this case, we're changing Harvey. So here we have, remember, you can print the permissions by typing ls-l to look at permissions. Changing file ownership, we have the commands chown and chgroup. So we'll play with those commands a little later today. But you can see here we have chown, and basically the syntax is new owner, which would be the user, and then file1. Now, remember, we talked about the -R, the -R recursive flag. So if you need to change the ownership of an entire directory tree, use the -R command or flag. So here we can see an example of it, chown -R Harvey, and then we have a folder basically. So there recursively, all the files should get updated. Okay, here's another example. chown -R Smith and Chem, so changing the user and group for a file. Okay, so that's, this is the syntax for change group, chgrp, # new group name, file1. Okay. So now we are ready to talk about access control. If you remember that I've mentioned this several times, and this is a very important concept. Whenever you want to see access control of files in a folder, you can type ls space -l. So you can see there's the command again. Okay, and it shows all the permissions, etc. So let's take a look a little bit more closely. So access control, also known as file mode. So there are 3 types of file access. So there's read, write, and execute. And there is, in fact, a 4th one, which is this S, which we will talk about a little later, but it's called the SETUID parameter. And it's really important, actually, for security situations. Okay, so we'll talk about that. The access classes are basically 3. You can see we have these 3, then these 3, and then these 3. These are basically the user class, the group class, and the other class. So user U, group G, and O for other. And they refer to basically the owner of the file, the group that has access to the file, and then the rest of the world, basically anyone else in the operating system. Okay. Any questions so far, guys? Okay. Right. It's like talking into the abyss. All right. So we have, once again, to iterate here, we have ls-l. Now, remember I mentioned that when the first parameter that you see, the first value is the file type. If it's a hyphen, it's a plain file. If it's a D, it's a directory. Then you would see rwx, r something x. This just means that that is not enabled. Okay. So this file, for instance, is owned by root user. Group is root. It's called file1. And here we know a lot about this file. Who is allowed to write to this file, for instance? We can say by the W that it is root. What about the rest of the world, where you see the arrow? Is the rest of the world allowed to write to this file? And the answer would be that it's not. Okay. Right, and we know that because there's no W here. However, this file can be executed by anyone. So it might be like a helper file or something that should work in a specific way, but everyone can use. But writing is pretty important, because obviously you can change an important file, etc. chmod is the command that we will look. I think we have looked at it a little bit at the beginning, the first 2 weeks of the semester, just to see how we could change permissions. So there are, in fact, two ways in which we can change the access modes of a file. One is this one, which is very intuitive and easy to do, but it might require several steps to change all the parameters. So you can do chmod u, and then we add the right privilege to the user, right? So you can see the user would be over here, owner. It's just an example for the file. There's also a numeric file mode, which is pretty interesting. You guys have taken your truth tables, etc., and your binary courses, so you know exactly how to convert from decimal to binary, and it basically uses that approach. Okay, so for instance, let's say that we want to convert a file. So, or you might see this, right? So you might see there's a file one, and I'm going to use the chmod command, and I want to change it so that the flags look like this. But you see that it was changed based on numbers like these over here, right? So you guys see that? So they were changed like that. And so how do we get these numbers to 754? Well, as it turns out, we can create this little table to help us out. So we have the user here, we've got the group here, and then we've got other. All right, so now we look at the modes, RWX, 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 right? And we're going to use binary numbers to indicate if they are present or not. So if RWX is what we want, then it's 1, 1, 1, because they're present. In group, we want R and X, so that's 1 and 1, and this is a 0. And then in other, we have R, nothing, nothing, and that gives us a 1 and a 0, 0. Okay. So how is that converted into integer numbers to get that 754? Well, the way that we can think of it is we can always imagine that, like in binary numbers, when converting from decimal to binary, we work our way from right to left, so in that direction, right? And so we know that these numbers, it's binary, so it's 2 to the something, right? So 2 to the 0, 2 to the 1, 2 to the 2, based on the position. So this position is 2 to the 0, this position is 2 to the 1, this position is 2 to the 2, and then we just multiply times the digit here. So in this case, the 1. So for instance, 2 to the 0 is 1, times 1 is 1, 2 to the 1 is 2, times 1 is 2, 2 to the 2 is 4, times 1 is 4. And so here we have 4, 6, 7, and we get our 7 value. We can repeat this with the next one. So notice here, it would be 2 to the 0, 2 to the 1, 2 to the 2. We have 1, 0, 1. So 2 to the 0 is 1, times 1 is 1. There we go. 2 to the 1 is 2, times 0 is 0. And then 2 to the 2 is 4, times 1 is 4. So we end up with 4 plus 0 plus 1, which is equal 5. And now we have our 7, 5. And then the last one would be, although it's not here, it's kind of meant for you guys to kind of see the pattern. 2 to the 0, 2 to the 1, 2 to the 2. Both of the first two are 0. So we just look at 2 to the 2 times 1, and that's going to be 4. So we end up with our 754 there. And that gives us basically the result. So now we can go ahead. Imagine this file didn't have flags such as these. But if we do chmod 754 file 1, then we would end up with a file that has those parameters. Any questions, guys? Does that make sense? No questions? Okay. All right, great. So yeah, so hopefully that makes sense. We'll see sometimes in examples, etc. It'll be the numbers or it'll be the, and you'll have to convert back and forth. So now you have a sense of how this should work. So hopefully That's gonna be good. So let's talk a little bit about like issues with Unix and Linux. So a best practice is to always, and I think I've mentioned this, don't overuse sudo. Think about your files when you create them and their access control. Okay. You basically want to ask yourself, how can I recognize a file access problem? Okay. A file access problem is usually one of the most common things in Unix, right? So if you remember, Windows, pretty much didn't used to have this problem, right? You would log in, no account, files, you had access to all of them. And why was that? It's not that Windows was a bad operating system. I mean, they were pretty good operating system. That was just a choice, right? So it was a choice because the idea with Windows in the beginning was to make it usable to everyone, right? Very easy to use. It's got to be easy. This feature of Unix made it so that people didn't like it, right? Because, oh, why is this file? So it was frustrating that you could never get things to work, and it's because of the file access control. As it turned out, we've learned over the years that that initial way of just having everything pretty accessible meant that the computers would get like a computer virus, and it would just like kill the computer and everything. And so you have to wipe every format cc ... right? The famous command. And so then we've got Windows has gotten accounts, right? And there's more restrictions, etc. And it's because of this, at the end of the day, it's just the access control of the file system. So as it becomes more like this, it becomes certainly more secure, but it can be frustrating, especially for users that don't deal with this all the time. So, and in general, even if you do, a lot of the time, your problems could be related to just some strange file access. Okay. So it's usually referred to as one of the most common issues. Now, one way of testing things out in case you encounter a problem sometimes is just to switch user accounts. And you don't have to switch to root. You can just use the sudo or account just to debug and try things out if you're encountering a problem and you don't know. Because if you get it to work with, you're trying to access some file and you do get it to work with sudo, but you can't get it to work with the regular user, then it could mean that there's some kind of underlying file access control issue. So we can say that in Unix, it is safe to say that everything is a file, right? So we've talked about this. Input and output devices are represented as files, right? So you have a file representing a printer, regular text files, right? That's what they are. That a directory, as we have mentioned already, when we think of a folder, etc., it is also a file, basically just containing a list of the files that it has. So everything is configuration-wise is going to be files, and we can we'll see that as we configure a few systems throughout the semester. All right, so that was kind of some brief discussion on access control. The next thing we're going to look at is the links, and we've got symbolic links basically. A link is a mechanism that allows several file names to refer to a single file on disk. All right, so a classic example of this is that, let's think of something like Java. So GRE 7.8, then it gets updated to 8.8, right? So it has to do with versions, versions that get updated in the underlying background of the operating system. But you may have a whole bunch of programs, and what if those programs have to import this GRE? So if you had that it should import GRE 7.8, but then you update it to 8.8, you're going to end up having a problem. So one nice way of solving this problem is that you create a variable called, let's say, Java default. Java default. Imagine if you did an ls-l in the system. We'll do this a little bit later. Java default would seem to be a file, and it's a file name, but actually you would see that it's a symbolic link pointing to an actual file. And so then other programs, etc., can just refer to Java default as if it was a file and then get the GRE 7 or 8, etc. Okay, so this is a nice approach, links, and we'll you can see them in the operating system. We might take a look at some of those. There's a common place to find some of these is the etc folder, but we'll look up the ln command to try to create a symbolic link, just to some temporary file, etc. Any questions, guys, so far? Okay, no questions. So another topic that we discussed on last Thursday actually is sockets. So in this course, we use some scripting tools, Wireshark and Scapy and other ones to kind of look at network packets and get a feel for, you know, and networking, right? If we're looking from the point of view of the Unix system, how can we access our packets, etc. So one important concept is sockets. There are special types of files. These are special types of files in Unix used for communication between processes. Okay, so imagine you have a space in the operating system. You have something like gedit and then LPR. So LPR might be a daemon, which we will define in a second. And it really is basically the process that is representing the printer, the process running for a printer. And then gedit might be like an editor, like Word, for instance, but for Unix or Linux. And so for them to communicate within the operating system, the software can use sockets. A socket may be thought of as a communications endpoint tied to a particular local system port. Okay, so you're going to have, remember, the local system and the port number information. So this is an, you know, here we have the LPR process may send information finally to the dev printer, which is the file that would stand for the actual hardware, which is the printer itself. And all of this can be done through this communication idea within the operating system. All right, processes. This is an important concept that actually has a bit of a abstract meaning. We know, of course, that we have files. Some of these files are executable, but when we execute these files, they become something that's running, right? So a process. Okay, we can see processes with the PS command. You probably use that one. It's something else that we can practice today. In simple terms, a process is a single executable program that is running in its own allocated space. Now, some processes, like a script, for instance, a Python script that we run sometimes, or a C program, etc., will be associated with the terminal, right? So if we run them on the terminal, it's kind of like they're running, the terminal is associated with them. Other processes are not associated with any terminal, and these are called batch processes, okay? So we don't need a terminal to start them. These are then the ones like daemons, for instance. So whenever your operating system starts, when the computer is booting, it's going to run several scripts that it has in the boot folder, maybe, or init.d, places like that. But these are processes that kind of run in the background. They don't need a terminal to start. They're just that. And some of those can be called daemons. Daemons here, you can see it, DAEMONS. Daemons are server processes, often initiated at boot time, that run continuously while the system is up. Okay, and they are waiting in the background until a process requires their service. All right, so these are the famous services, right, that we have available. And that you saw last week as we were talking about services that they have ports associated with them, right? So this week, I believe one of the commands we will explore is services. So somebody came in, I think. Okay. All right. So I think they went away. All right. So I was saying services is what we're looking at. We have the specific term daemons. Yeah. So they're associated with processes that have a port number. And basically it's this idea of listening. We have a service on listening on port 22 or port 80. And we were looking at these, we call this like open ports or closed ports. So if you remember, we were looking at a port scanner last week. And that's what I'm referring. So the more services you have running, the more ports you have on that server open, because they're waiting for people, for connections to be made to them. And basically, as you have a port open, you guys, I'm sure, know that then your device may become a little bit more vulnerable, right? This is the classic exploits that you studied in your ITS 250, where you have something, let's say, this is just an example, some kind of an Apache web server, some version. So that's listening on port 80. It has been detected that it has some kind of a vulnerability. Usually it's going to be a software assurance type of vulnerability, like a buffer overflow in the underlying C program, because memory was not allocated correctly. And so somebody might insert some data into that port to try to basically, get the vulnerability to trigger, right? And take over the machine. Usually their goal is to get the shell, root shell. So you probably did this with Metasploit or something like that, where you would run a script, it had a payload, it was maybe like Apache vulnerability or something like that. And it's just inserting code through that port into the software memory space, and then trying to make so some type of ports, buffer overflow attacks are on the stack of memory. So you try to overwrite that, and then overwrite places where you'd have return addresses, things like that, so that when the program tries to return to another part of the code, it actually jumps to some part where you have put in some bad code, and then that bad code executes. So you know that this is a vulnerability. That's what this is about. And there's a technique. It's basically more like a procedure that you practice to remove this type of vulnerability. Do you guys remember the name of that approach to mitigate these types of daemon and vulnerabilities and open port issues? Okay, so it should be called device hardening, right? So you harden the device. It really just means if you have a server with multiple services, if you're not using them, turn them off, the more you have open, the more exposed you may be. And also another important practice is to update, right? So funny as it sounds, is you just update the software as the developers are probably investigating their own software, and they may find a vulnerability, they want to update the software. But those are usually, falls under device hardening, and that's what this refers to. So services are really important, and that's another security issue in Linux. Linux, is used a lot for like servers, like cloud web servers are very common, or email servers, DNS servers. Nowadays, there's a lot of like performance, high computing servers as well, right? But those are basically the ideas. All right, so some important Unix daemons. We won't look at all of these this semester, but we will look at a few. So we've got the init, we've got syslog, we've got email, printing, web, DNS, cron, and so on. So one of the first ones we will look at probably next week, I believe, is going to be cron, which is this one. This should be really nice and interesting. That's the cron. Notice that the daemons, because it starts with a D, they sometimes add the D to indicate that that's a daemon, and tells you that it's it's a process running in the background associated with that service. All right, so cron D. LPD is for the printer. Send mail could be one of the services for mail. There's several. Syslog D for logging, for log, actually. It's a service that's really nice, so that machines can send a lot of their information maybe to a central logging device. There's quite a bit of that going on. We'll see something like that with SNMP also later in the semester, as we discuss some of these services that are more distributed than others. So some services are very local. Cron, for instance, is very local to the system, whereas something like syslog or SNMP might be more distributed. So cron D, anyone know what cron D is for, or cron? You use cron in some capacity? Okay, no one maybe. Cron should be fun. I mean, I think you guys will like cron. It's a task scheduling service. So basically, it's really exciting because you can schedule a script. Let's say a Python script or a Bash script, and you've written some code in that script, but you want to run that. You need to run that script, maybe to back up some files every Tuesday and Wednesday at 2 a.m. So then you can use cron basically to schedule that. It's got its own syntax and kind of its own language of how to, in one line, you encode all of that, and then you can run commands or scripts. So it should be pretty interesting, and we'll start exploring that next week. All right, so now let's talk about process attributes. So we'll see in a second. We have the PS command, and that's for processes. Basically, that'll tell you the processes that are running, so we can start a script in a loop, possibly. We might do something like that. And so let's imagine it's cron D. If we do PS, the process would list, just like before when we do ls-l in a folder, we can see the files contained in that folder and the access control of it. Well, here, if we want to see the processes running, that not necessarily the file it generated, but the actual process as it's running. And so we're going to be able to see it this way. They usually have an ID associated with them called a PID, which stands for the process ID. And if we, for instance, wanted to kill a process, like we want to stop it, we have a nice command called kill-9, and we just need the ID of the process. So that's something else that we can explore. Today. All right, so now we're going to get into something a little bit more complicated. So certainly ask questions if something is not clear. These are definitely going to be like questions on the exam. This ties into processes that are running. It has to do with permissions and access control, because it's not just about files, right? Remember that files have that little X parameter. So we have RW, but we also have X. So we are really talking about X here, which is the program or the process as it's executing. So there's quite a bit going on there. But it's a way of thinking about access control in relation to how that process is going to run in memory. Okay, so imagine that when you have a file and you run it, you kind of like create that file in memory, and that file is now running, and imagine it's got like a fence around it, and that fence means you're only allowed to access the stuff within the fence. Well, those things within the fence depend on the ID of the user. Now, we saw last week that the ID of the user seed is 1000. However, a process, whenever it's created, it actually is associated with two IDs, not just one. Even though the user has one ID, the process will have these attributes, let's call them, where you have two IDs. These two IDs you can see here listed. They are the RUID and the EUID. So the RUID stands for the real user ID, and then the EUID stands for the effective ID. So usually the real ID and the effective ID. So a process's real ID is the UID of the user who started it. Okay, so imagine here we have an executable past WD. We started as normal user. You can see the $sign there, and it's Smith. And Smith, it has an account 1000. So then if you imagine the process as it's running in memory, the real UID is 1000. However, we also have a possibility that we also have an attribute called the effective ID. Usually those two will be the same, 1000 and 1000. But there are situations where the real ID might be 1000, but the effective ID could be, for instance, like in this example, 0. So if you remember, 0 is the account, the ID of the root user, right? So that means that that process, even though the real ID is 1000, and even though the user is 1000, the process is running with the effective ID of root. Okay, and that's important for access control because really that changes what this user can access by having this control. So its effective ID is the effective ID is the ID that is used to determine that process's access to system resources. So it's really what the operating system will look at. And so in this example, with an EID of 0, basically you could, a program would look at that, and then it would try to, it's a program, right? So it's got instructions of what it's going to do. So the program will run and follow the instructions, but if there is a file that is only for root, in the scenario where RID and effective ID are 1,000, the program will just not access the file, and it'll say access denied. But if it's following its software, its commands, and it tries to access the file, which is root own, and it checks the RID as 1,000, but then the effective ID is 0, then it will be able to access the file. Access will be granted because of the effective ID. So the question is, what is the mechanism that would allow this to happen? Because in general, the effective ID and the real ID will be the same one, and it'll be 1,000. But there is a situation where actually this could happen, where the real ID is 1,000 and the effective ID is 0. Okay, and so that's the next topic that we're going to discuss. Are there any questions on this idea, guys? Any questions? No questions? Okay, all right. I believe you're still listening. So the situation is, well, we need to talk about the situation and then the mechanism. So the easy one to answer is the mechanism name is the setuid command. So it's setuid, set user ID. It's a command, basically. That's what could allow this to happen. So for instance, setuid 0. And so you set it to 0 for this process. What would happen when something is setuid is that if you remember, going back to access control of a file, not all files would allow you to do something like that, but files that have, I have it here. Yeah, files that have this S parameter would let that happen, the setuid parameter. So we'll break this down. But so we want to think, so the question is, to understand this better, is what is the situation where we would need to have, and you can see that's the last topic, setuid. What's a situation where we would need to have something like that? So let's think of the following scenario, okay? We have a program, X, and that program, we're going to use it. We're seed, but we're regular user. We're not going to use sudo. We're not sudo. Instead, we are just going to run it as regular user, but we have a legitimate reason to use the program and to make a change to a file that is root owned. Okay, so that's the trick. There's a file. That file is root owned. We need to make a change to it, but only root can write to that file, and we are regular user. So how do we write to that file? We cannot write to that file directly. We can only write to that file through a program, but that program needs to allow for that to happen. And so the way that it's going to let that happen is through the setuid command. Yeah, so that's basically the idea. So what's a situation that you can think of where that would happen? Can anyone tell me if you can think of a situation, like a legitimate situation, where you would need to make a modification to a file? The file is root owned, but you're just a regular user. What are some ideas there? No ideas? Nobody? What about, you're a user, right? What if you were gonna, oh, someone's, I think, speaking. Change your password. Yeah, there we go. Nice. Okay, Lorenzo, thank you. Exactly. Good. Sorry, I missed that for a sec there. Yeah, exactly. Changing your password. That's a great answer. So the situation is that if you remember, you have the passwd file, you have the shadow file, which is root own. And how do you modify that file, right? So what needs to happen is there's going to be a program, a passwd program. And then that program would need to be owned by root. And if it's owned by root and it has the S flag, then when we run it, what would happen is we would effectively assume the effective ID of root, right? And that effective ID can be used by the program for that specific task. Now, remember, I'm not saying that you get the root ID and now you're root for everything. That's not how it happens. It's all within the context of the program. So the program, all it can do is access that one file and write to it. So that's all that you'll be able to do with that function, but you will be able to modify the file because you have the root of the effective idea of root, basically. So that's kind of the idea there. This is achieved through a command called setuid, which will do that. You set the file, the process to be root owned and setuid, and then when somebody runs it, they can get the privilege. Now, obviously, what hackers like to do is they want to make it in such a way that you can break out of that program, right? But retain the root privilege. So that would be a type of an attack that has been targeted in the past, just getting that root privilege. Any questions on setuid and that idea? Or any of the ideas we've discussed? That's kind of the lecture slides for today. And then we're just going to practice on the UNIX operating system. We will come back to setuid quite a bit, as this is an important concept that can be confusing. I know in your software assurance class, you actually have some attacks where you look at setuid related things. So any questions on the slides before we move on to working on the VM? I think that, yeah, so that's the last slide there. All right, so I'm not seeing any questions. All right, so let's keep going then. Gonna go back. I'm just what? Yeah, I'm gonna go back to content here. Okay. Let me move this over here. All right, so table of contents. Okay, and then we're gonna look. We looked at these. That's the same slides in PDF. You're gonna read this, and now we're gonna just go over some of the commands that we discussed here, and then we're gonna go through some of these commands here that to practice a little bit more on the UNIX operating system. I have these commands here. Let me get them here. All right, so the next part of today, we're just going to go through some of these commands, as I said, on and practice them. And then we'll come back to the Word document as well and practice on that. All right. So, all right. I just opened my virtual machine. So you guys hopefully should be seeing the VM. Okay. So let's open the terminal. I'm going to do ls-l here. Just okay. I'm going to navigate to my desktop. Okay. Oop. Didn't press it. All right. So I'm going to hit clear ls-l. Okay. So now I'm going to go into I'm going to cd into ITS 372 spring 2024. Okay. And I hit clear. Why is that? All right, clear ls-l. Okay, and then here, you know, we may be writing some scripts, etc., or just really just looking at commands. So let's take a look at some files, right? So let's create a file here. I'm going to create a folder, actually. I don't want to damage these files. So I'm going to do mkdir, and I'm going to talk about permissions, examples. Okay. So I'm going to cd into that. Clear. All right. Let's create a file here. Let's call it temp1.txt. And we're just going to say hello. Okay, Control X, Y. All right, so I'm going to hit clear ls-l. All right, and we can see temp1.txt is owned by seed, and we've got the rw r permissions, access control. So let's do chgrp, right? So like the command says, and then we need to think of a new group for this file. So let's do root, which is probably not great. And then let's try temp1.txt. Not permitted. Okay, let's do sudo. Okay, and now I do ls-l, and you can see I've managed to change the group there to root. This file can be read by everyone. So let's make it so that it can only be read by seed. So let's do actually, I'm trying to think. Yeah, let's make it so that it can only be read and written and executed by seed. So how would we do that? We can do that. We can look at our little table from the slides, and that would be 700, right? So I'm going to do chmod 700 temp1 txt. So I run that command. And what do you guys notice? You notice that these parameters are here, but all of these went away. Remember that all of these would be zeros, so that's why it's 0, 0 here. The 7 just means there's 1, 1, 1, so that's 2 to the 0, 2 to the 1, 2 to the 2. So that's 1, 3, 4, 7. So that's why we got this to work. Any questions on that idea, guys? Okay, it doesn't sound, I'm not hearing any, so let's go then to okay, so yeah, sorry about that. All right. Let's go ahead and add change permissions again, but this time let's do it the other way. Instead of with the numbers, we are going to use just the U and the plus W. So we want to add read permission here, this one, to the group. So this should be chmod. That's going to be G, correct? Plus R. And then temp1. Okay. So we do ls-l. We added the R back. We also want to add the W back, so we can just do GW. Okay. Let's hit clear here, ls-l. And we can see read and write. And then what else do we want to do? What if we wanted to add read permissions just for the rest of the world? How would you do that? We can add an O here, correct? Try that. Oh, that's a 0. Oh, okay. All right, so I'm going to do ls-l temp1.txt, and you can see there, we have basically the permissions, I think, back to how they were before. We want to change the group back to the way we had it. It should be ch what? What was the command? Do you guys remember? So chgrp, what? Seed, correct? Seed. Now here, let's see what happens, because we're taking away root's permission, so it let us. Now it may be that it still remembered that we were sudoed in. So you can see this is back to seed. Any questions, guys, on how to play with file modes in a file and basically access control? Any questions? Okay. All right, so not hearing any questions. let's go ahead and, oh yeah, links. Let's look at symbolic links. So a good place for these, well, actually, let's create the command for creating a symbolic link is anyone know the command? Nope. All right, well, let's try. I'm going to do a simple example here. I'm just going to create, so I'm going to do clear ls-l. I'm going to create another file. I'll do nano temp. Actually, let's use a different name. Let's do like program 1.bin. Okay, program 1.bin. Extension doesn't matter. And let's just say today is Tuesday, I think. Tuesday. Okay. So let's look at both of these files, ln-l. So now we want to create a symbolic link between one and the other. So what I'm going to do is I'm going to say try ln dash s for symbolic. And so we are going to link to temp1. So I'm going to say temp1 .txt, and then I'm going to add program 1.bin. And actually, I think this should be another name, not a file. So I'm going to say .bin like that. There we go. So I don't, because both of those are actually files, okay? And so I was doing that wrong. Really, it's just like a name to an actual file. But if I do ls-l, notice what just happened. Effectively, it looks like I have 3 files, right? If we do this analysis, we would think, oh, I have 3 files. But really, I created this file program2bin. You can see that there's an arrow which indicates it's pointing to temp1 txt. And you can see over here, it's got the word L, which indicates links. So now you have seen that for this column, we can have the hyphen for file. We can have the D for directory, and now an L for link. So the next thing we might want to try is let's read. So let's do cat temp1. Cat temp1 says hello. So I'm going to do clear. Now let's, let's do ls-l. Now let's cat program2 bin. And notice that it says hello once again. Now, what if we did something like cat or echo, echo dog type program2 bin. Might want to do redirect actually. Or this one. Okay. All right. So now I'm going to do ls-l. And I want to take a look at cat program2. You can see that the word dog is there. Now let's access temp1. And you can see that the word dog is there. So we effectively wrote to the symbolic link, but we were able to overwrite the real file. Now I was thinking of a scenario. But we would have to change the ownership of this file. So it's fine for this. I think this illustrates what a symbolic link is, which is really what I was trying to illustrate. So it's really just the name that is linked to another file. Okay. Any questions, guys? All right, so let's go ahead now and let's go ahead and just look at some actual symbolic links. So I'm going to go to the etc folder. So we can go to etc here. Okay. Yeah. And there's a lot of files in here, but if we look, we'll find some that are symbolic links. So we have, for instance, here's a link. You can see the L right there. Here's another one. See the L right there. This is resolve.conf. So this is actually for name resolution for DNS. Look at this one, OS release. Notice another symbolic link. Another symbolic link related to mounts or the mounting system. We'll take a look at this at the end of the semester. Here's another one for local time. Notice how it points to some file. New York, it says, for the zone info. Quite a few symbolic link files there. Okay. Any questions, guys? So that hopefully illustrates the idea behind links and what they are for. All right, so let's go back to our notes here. So we covered links, I think. I'm not hearing any questions. So now the big topic that we have is processes. So let's get out of this. So this is a good to practice. Where are we? PWD. Okay, we're at the root. So then we want to go to home. Clear ls-l. Then we're going to go into seed, which is our regular account. ls-l. Then we go into the desktop. Clear ls-l. All right, and now we can go to our ITS 372. So I'm going to do cd ITS 372 spring clear ls-l. And let's go into permission examples. Let's just stay there. Clear. All right, so we're back here. So now we're going to think about processes. Okay, so let's go ahead and do PS. Okay, these are some commands that we have there. Let's create a Python script here. I'm not sure this will work, but hello world.py print, because it's got to stay running, I think. So for, I'm gonna do while, this is not a good idea. While true, but I just want to try this. True, colon, 1, 2, 3, 4, I equal I. Oops. I'm gonna say I is equal to 0. So 0. Yeah. All right, just something. Maybe I'll do I plus plus also. Do a little bit more processing there. Okay, so yeah, I'm not adding any. This might fill up, but I think not quickly enough. All right, so I'm gonna do Control X, Y, and I'm just gonna run this. So I'm gonna run PS first. I'm trying to create a process. This may be a bad way of doing it. I'm gonna do Python. Okay. Doesn't like that. Why not? There. Okay, so the process is running, right? So that's what is happening there. So now I'm gonna open another terminal. Okay. Okay, there it is. And I'm going to run PS. Yeah, it doesn't show that process. Uh, Probably the bash. So if I want to kill this process over here, right, what I think I need to do is kill this bash, my bash shell. So I'm going to do kill. Kill -9. And then the ID, which is 5861. Let's see if it kills it. It killed the one I was using over there, but I wasn't able to kill this one. How can we start a process? Yes. See, there it is. It was that Python 5847, but I could only see it on that terminal. It's probably not there anymore. Anyway, I can remove it now. 5847 killed. So, PS, sorry. So it's not there. So we got rid of it, but it's not quite what I was trying to do. I'm trying to think. Let me try sudo service Apache to start. Okay, now let's do PS. Oh, nope. All right, so we need to think. So if you guys can help me out, be interesting to start a process that we can kill. Something fun. Any ideas? Let me try. Man HTTP server. Port 8080. Oh, it's dash P. P. Ampersand. Okay, command not found. Although I think it's running, but I do PS here. Nope. Yeah, so we're gonna have to think about this one. Just curious about it. But I can't seem to start a process. This usually happens to me when something is running and it's just, I want to get rid of it, but I can't remember in what situation I've created one of these. Well, that might be a nice homework for you guys. Mhm. So jobs, is that still running? Nope. Let's try another one. I have one example here that might. All right, so let's do gedit, which is the editor. Gedit. The ampersand should send it to the background, I think. So what I was trying to do before. Is that an ampersand? Okay. See, it opened the gedit here, right? That's the program that you're seeing, and the terminal says it's 6113. Now, if I do PS, yes. All right, it worked, right? So there it is. Okay, fun. All right, so yeah, so we created a process, gedit, in some process, ampersand 6113. We can see it's running there as 6113. And then we can try to kill it, kill -9, and then it's the ID over there, 6113. So 613. Okay, you saw the background went away, which means we killed the gedit. So that's great. I'm pretty happy about that. Let me see if I can run my, where was that Python that was wasn't hello one. Oh, it is. Okay, so let's try this one. It would be, you guys remember? So Python hello ampersand 6238, it says. PS. There it is. All right. So we've got the mechanism. And you can see it's kind of slow because when I type, it takes a while because it's doing that while loop and that's consuming a lot of the CPU. So jobs, see, it's another command that shows what's running, tells you which script. PS gives you the ID. And then you can see it's slow because I type and it's pretty slow. So I'm going to kill it. -9. Oops, sorry. -9. What is it? 6238. Oh, no. Sorry. It's the lag in this thing. It's okay. 626. 6238. There we go. Okay, so hit enter. Command not found. Okay. I think I'm missing a space. There we go. Okay, so did that. PS is still there. And it's still pretty slow, actually. So, well, now I really need to kill this. Didn't work. PS. Oh man, because of this lag, it's really. Okay, 6238. Kill space -9. No. 9 space 6238. 623. Hit enter. Okay. PS. It's gone. There we go. Perfect. So before we had bash Python on PS. Now we have bash and PS. Okay, perfect. You can see it's more responsive. It's really good. Perfect. Any questions, guys, on that example? Any questions? Is it making sense? Processes? No questions. All right, great. All right. So good. So we practiced some of these commands today, or basic commands. Talked about daemons, which that's part of your lab on Thursday. So we'll talk about that on Thursday. Yeah, the daemons and services. We'll talk about that on Thursday. Talked about the kill command. Then we have SETUID, the real and effective ID. We need to talk about that on Thursday. All right, so yeah, so that's the lecture for today. I'll stay for a few minutes. If you guys have any questions, let me go ahead and stop sharing here. I'm going to stop the recording.